Welcome to Summarize Science, where we break down the latest research. Today, we're looking at a huge problem in AI and robotics. The most powerful AI models are massive and expensive, making them impractical for most real-world robots. But what if you could teach a much smaller, more efficient AI to be just as good or even better? This paper introduces a new framework called ERA, the Embodied Reasoning Agent, designed to do just that. It's a two-stage process that first gives a small vision language model foundational knowledge and then uses online reinforcement learning to improve its performance. Think of it as putting the AI through school and then giving it hands-on job training. The first stage is called embodied prior learning, which is essentially the AI's education. It learns foundational skills from 3 different types of data. This gives the small AI the basic knowledge about the world and how to perform tasks that it naturally lacks. First, it learns from trajectory-augmented priors, which is like reviewing past attempts at a task that have been annotated with notes and reasoning by a much smarter AI, like GPT-4. Second, it studies environment-anchored priors by answering questions about its environment, like identifying objects and understanding the correct order of actions. Finally, it learns from external knowledge priors, which are general datasets that teach it skills like spatial and logical reasoning. The second stage is online reinforcement learning, which is where the AI practices what it learned. It tries to complete tasks in a simulated world, learning from trial and error. The researchers made a key improvement here called self-summarization, where the AI learns to create a concise summary of its past actions, helping it manage long tasks without getting overwhelmed by information. And the results are incredibly impressive. Here you can see the ERA agent identifying and correcting its own mistakes during a complex, multi-step task. On the bottom, it demonstrates the precise low-level control needed to place a star into the correct slot of a shape sorter. Looking at the numbers, the small ERA, 3B model, with only 3 billion parameters, consistently beats the much larger GPT-4. On high-level planning, it scored 65.2% to GPT-4's 56.8%. On low-level manipulation, it achieved a 48.3% success rate, crushing GPT-4's 28.9%. This demonstrates that a smarter training method can be more important than just having a bigger model. So let's recap the key points. The researchers created a two-stage training process called ERA. First, they give a small AI a specialized education with 3 different kinds of knowledge, and then they let it practice in a simulated world, learning from its mistakes. The result is a small, efficient AI that can outperform massive models on complex robotics tasks. What this means for the future is huge. This could be a major step towards making powerful, intelligent robots more affordable and accessible. Instead of needing a connection to a giant, expensive AI in the cloud, robots could have this level of intelligence running on their own, more modest hardware. Thanks for watching.